Welcome back to Chapter 3. In this chapter, we're going to be looking at techniques of integration. So you may remember in some of the homework problems that we had in the last chapter, in my notes, I had some problems. I said, I apologize, but we don't know how to integrate this yet, but we will learn how to integrate it. Well, we are at that point in time where we're going to learn some new techniques of integration. The only two techniques for integrating that we know right now, other than some basic trig formulas, is substitution and the basic power rule. So in this chapter, we're going to learn how to integrate using a variety of new techniques. But a word of caution, integration, unlike differentiation, has many problems that you can't integrate. You can differentiate almost any function, but integrating many functions is impossible. And so one of the last things that we will be learning in this chapter is how to use technology to integrate. And in particular, we will be using Desmos. All right, that having been said, let's get on to our first technique, which is integration by parts. So integration by parts is integration's answer to the product rule. Just like substitution was integration's answer to the chain rule, and the power rule was integration's answer to the derivative power rule, this is the how we undo the product rule. So let's say we have a function h of x that is equal to the product of two other functions, f and g. If we take the derivative of both sides of that equation, we end up with this, right, using the product rule. So h prime of x is f prime times g plus g prime times f. Then what we do is we take the antiderivative. We integrate both sides. So remember, integration is just, when you don't have bounds of integration, you're just finding an antiderivative. So when we take the antiderivative of h prime, what we're doing is we're finding the antiderivative of the derivative of h. Well, they cancel each other out, and we end up with just h. Then what we do here is we're taking the integral of the right-hand side of our product rule, and then integrating both sides, or both terms, term by term. And so we end up with this. We end up with h of x, which is the product of f times g, is equal to these two integrals. Then what we want to do is we want to solve it for this particular integral, which is this one right here. So to do that, we have to take this and subtract it to the other side. All right? And we end up with this. Okay? We end up with the integral of f times g prime dx is equal to f times g minus the integral of g f prime dx. Now that looks pretty complicated. I wouldn't want to memorize that. So we make it a little bit simpler. We turn the f's and g's into u's and v's. And so integration by parts, the basic formula that you need to know and learn to love, is the integral of u dv is equal to u times v minus the integral of v du. That's really not that hard to memorize. And this is the important part to memorize. uv minus the integral of v du. All right, so let's just do one real quick example, and then I'll do a little more explaining. So in this formula, we have, so we're given this over here. This is what we are given. We are given u and we are given dv. Let me get rid of this. We are given u. We know what u is. We know what dv is because that's on the left-hand side of the equal sign. And so what we need to do is we need to figure out what u is and what dv is. Now, u stands for some function that we're calling u. So if we go back to this, you'll see, let's use green. You'll see that u here was taking the place of function f. right? Now, which function we call f doesn't really matter. We just need to call u one of our basic functions. And then dv will be whatever is left over, basically, all right? So let's just take a look at how we do this problem. We have x times the sine of x. Now, first of all, how do we even know that we have to do integration by parts? And the way that we know that we have to do integration by parts is that we have two completely separate different functions. We have function x, which is an algebraic function, some power of x, and we have sine of x, which is a trigonometric function. And there's no way to simplify that, but they are being multiplied together, so we have to use the product rule. So what I'm going to do is I'm going to let u be equal to x. And so that's what I do right here. I'm let u be equal to the function x. Well, that means that dv has to be everything that's left over. dv then has to be the sine of x dx. And you have to include the dx in there. So here's what we do now. Once we've done that, say, okay, if this is my function u, what do we have to find in this formula over on the right-hand side? We have to find du, which is the derivative of u, right? Right there, we have to find the derivative of u. So the derivative of x is just 1 dx. And then what else do we need to do? Well, we need to find v. Right? We need a v there, and we need a v there. So how do we find v if we have dv? Well, what does dv stand for? It stands for the derivative of v. So what we have is the derivative of some function v is equal to the sine of x. That's what we have right here. So if we have the derivative of a function and we want to find v, we take the antiderivative of it. And so we're going to take the antiderivative of the sine of x. And the antiderivative of sine of x is the negative cosine of x. And that gives me my v. So what we're really doing here is we are starting off with identifying a function u and finding its derivative. We are then taking the rest of what is there and calling it dv, the derivative of v, and finding its antiderivative. So in one problem, we are finding derivatives and finding antiderivatives. And so I like to do all of this over on the side. Okay, do it kind of separately over here. This is the way that I prefer to go about doing these. And then what we're going to do is we just put it all together in the formula, which has gotten pretty sloppy over here. Putting it all together in the formula. So here's the left-hand side. This is my u dv. And so it equals u times v. Here's my u times v. U is, let's kind of erase some of this stuff here again. So u is x. That goes there. V is negative cosine x, so that goes there, and that's where the negative comes from. Negative x cosine x, you're basically multiplying those two together. Right? Then in the next part, over here, we have a minus sign, and then the integral of v du. Okay, so v, and here's du, so we have to put these two together now. So it's the integral of negative cosine x dx. And that's what we get right there. Well, whenever you've got a bunch of negatives, simplify those before you make a sign error. So we have a double negative, which becomes a positive. So we simply have negative x cosine x plus the integral of cosine of x. So you'll notice that means we have to do another integration within this problem. That's no problem. By the time we get to here, we should be able to integrate that using some basic formula. So the antiderivative of cosine is sine. And so we just bring this part down, add the plus c, and we're done. That is integration by parts. Now, if you wanted to check your answer, you could find the derivative of your answer. And when you find the derivative of this and simplify it, you will end up with what you started with. Let's do another example. But first, let's talk about the assigning of whether something is u or v. So choosing u and dv is very, very important. And so I'm going to take a little bit of time to talk about liati. L, however you want to pronounce it, I-A-T-E. Now to remember that some people say living in a terrific environment or living in a terrible experience or whatever you want to do. Come up with some, acronym, some little saying to remember that. L-I-A-T-E. Now, L stands for logarithmic functions. I stands for inverse trigonometric functions, which we really haven't worked with too much in this class. Then A is algebraic functions. T is trigonometric functions. E are exponential functions. So when we select u and dv, we always put u to the right, dv to the left. To the right, I'm sorry. U is to the left, dv is to the right. That's the way I always do it. And the reason for that is because that's the way it's written in the formula. All right. So let's just say you have an algebraic function and a trigonometric function. Okay. You have an algebraic function and a trigonometric function. Well, which one is to the left? Which one is to the right? The algebraic function is to the left. The trigonometric function is to the right. And so that's how you would assign. The algebraic function becomes u because it's to the left of dv. And the trigonometric function would be your dv. Well, what happens like in that last problem? We had that was the last problem. So let's say you have a logarithmic function and an algebraic function. A logarithm. So you have a logarithm and an algebraic function. Well, logarithm is to the left of algebraic, so this is my u, this is my dv. With logarithmic functions, they always, always, always have to be u because they are the farthest to the left. No matter what other type of function you have, L has to be u. What happens if we have, like in this problem we're about to do, we have an algebraic function and we have an exponential function. Well, then the algebraic function is u, the exponential function is dv. So that's how we go about selecting u and dv. Let's do the next problem. In fact, we're going to do two problems. This one was pretty quick, so I squeezed another one in here. I hope you don't mind that. The second one isn't in my notes, but I just put it in there anyway, so you'd have another example. So this function is an algebraic and an exponential function that uses the chain rule. So we're actually, it's going to be the u substitution. So over here on the side, I determined that u is equal to the algebraic function and that dv is equal to the exponential function. So that means I have to find the derivative of x, which is just 1 dx. I have to find the antiderivative of e to the 6x. So remember when you're doing u substitution, I'm not showing all the steps on the u substitution, particularly with an exponential, because exponentials are pretty straightforward. When you go through the u substitution process, anytime you have an exponential with some type of a function other than x here, then really all you end up doing is taking that coefficient 6 and dividing by it. So dividing by 6, or 1/6 e to the 6x, is the antiderivative. So we have everything that we need. So now it's just a matter of packing it into the formula. So the first thing that we do is we take u times v. Multiply those two together, and we get this. You get 1/6 x e to the 6x. Now, when I write these out, I like to put the constants, the number part out in front as a coefficient. Then I like to write the algebraic part, and then I'll write the exponential part. Then we have minus, then we have to do v times du. And so v times du is right here. So we have 1/6 e to the 6x dx. And of course, I put the 1/6 out in front of the integral, as we always do. So now you need to find the antiderivative, once again, of this part. So you did that over here. It's going to end up being the same thing. So the antiderivative of e to the 6x is 1/6 e to the 6x times the 1/6 gives you the 1/36 e to the 6x. So a common thing to do in these problems is whatever you have over here is your dv and you find the antiderivative, you're going to be doing it again over here. Not every single time, but most times, particularly in the types of problems that we do. All right, so I squeezed in another one real quick. Here we have an algebraic and a trigonometric function. So down here, I decided what my u and my dv were going to be. So I let u be the algebraic function, 9x. The derivative of 9x is 9dx. So that means that dv has to be the cosine of 8x. And so the antiderivative of cosine is sine of 8x. And just like with the exponential, you need to divide by that number right there, which is 8, or multiply by 1/8. I prefer to multiply by 1/8. And now, once you've got this part over here, it's mostly just a matter of putting it into the formula. So u times v becomes 9/8. There's an x and a sine of 8x. Make sure you've got all the pieces in there. 9 and a 1/8 becomes 9/8. Minus, so now we want, do this in red, now we want v times du. And so again, I have a 9 and a 1/8, which becomes 9/8, and sine of 8x. And so I should have put the 9/8 out in front, but I didn't, but you know it goes out there. So now we need to find the antiderivative of the sine of 8x again. Okay? Over here we were finding cosine. Now we're going to find the antiderivative of sine. So the antiderivative of sine is negative cosine. And again, we have to divide by the 8. So divided by the 8 becomes a 64. This doesn't change. And so we end up with a double negative, which becomes a positive. 9/64 cosine of 8x plus c. So at this point in time, I'm going through many of the basic antiderivative integration formulas without doing a lot of explanation. I'm assuming that at this point in time, you guys know how to do these. And so I'm not going to spend a lot of time showing every single step. Hopefully you're doing that in your notes just to make sure that you don't make any mistakes. And I believe I have one more problem for this video. So we want to do, here's one with a logarithm, the log of x over x cubed. So remember what I said, the log of x always has to be your u, all right? So again, if you have L-I-A-T-E, living in a terrific environment, so we have L, and what else do we have? We have an algebraic. So this has to be my u and my dv. First of all, we want to simplify this because integration by parts undoes the product rule, not the quotient rule. We don't have something to undo the quotient rule. So we have to turn our quotients into products. So that's easy enough to do just by bringing that x cubed up to the numerator and making it x to the -3. So what is the derivative of the log of x? It is 1 over x. And the antiderivative of x to the -3 is -1/2 x to the -2. putting those together, we have u times v, which is right here, negative 1/2 x to the negative 2 log of x. I'm not doing any simplifying there, minus the integral of v times du. And so we bring those two together, and so we have the negative 1/2 x to the negative 2 times the 1 over x dx. Now it's time to simplify. We can bring this power of x to the negative 2 to the numerator, down to the denominator, and that's pretty much all we do there. We have a double negative here, which becomes a positive. The 1/2 comes out in front. And then, of course, we have x to the negative 2 over x, which simplifies to 1 over x cubed, or x to the negative 3, whichever way we need to write it. So we're going to keep it x to the negative 3 because we need to find the antiderivative of that again. So this just comes down. We're done with that. That's the u times v part. Minus the integral of v du. We have to find the antiderivative of that. Well, the antiderivative of x to the negative 3 is going to become this. All right, so I can just squeeze that in here. X to the negative 3. So using the power rule, we get x to the negative 2 divided by a negative 2. And of course, that's being multiplied by 1/2. So that becomes x to the negative 2 over 4 with the negative out in front. And then we're bringing the x to the negative 2 down. And so that is my final answer. Final answer is this. Be careful when you're entering these into WebAssign. All right, that's it for this video. There's only going to be one more video in this section. So see you then.